This is lipids continuation video number 3. And after we have seen how a triazole of glycerol is made, it's a triester of glycerol, it can be hydrolyzed using different conditions. The hydrolysis can take place using acidic conditions like any regular ester. Also can be done using enzymes, but the most important application of the hydrolysis of the esters of glycerol is the basic hydrolysis for the synthesis of soap. In this reaction, the product will be 3 fatty acids than a molecule of glycerol. Since the fatty acid is acidic, it's going to react with a molecule of sodium hydroxide to produce the salt of the carboxylic acid. It's very simple reaction like we have seen in carboxylic acids. If you have any carboxylic acid, it's gonna react with sodium hydroxide. It's the acid-base property we have said before. So you get the salt of the acid plus water. So I'm not indicating the molecule of water, but this reaction is taking place 3 times, so you get 3 different fatty acids. I was gonna write down the 3 fatty acids, but there is no need for that. And what we have next to continue is that how is that a soap can clean? Because once we have formed these 3 fatty acids, that is making soap. This soap can clean because the molecule, the ionic part where we have the carboxylate anion, can associate with molecules of water because this is water soluble part that is going to be forming a micelle. And in a micelle, you will have an amphipathic molecule. The word amphipathic means that it has double character. It has a hydrophilic character, that is the carboxylate part, and a hydrophobic part. So the hydrophobic parts are all going to aggregate, and when we are using soap, dirt or grease is going to be trapped in interaction with the hydrophobic tails of the fatty acid. Okay, now what we're going to discuss is a little bit of what are the components of membranes, what are the lipids part of the membrane. And we have 3 different categories. The first one is what is called a phospholipid. We will need to have a high content of carbon, but a phosphate unit will make a difference between having a phospholipid and having a glycolipid. If it is a glycolipid, now we need to bring the carbohydrate part. And then we will also have the units of cholesterol. Since we are discussing the membrane lipids require to be amphipathic. That means that we'll have one part that is going to be hydrophilic and one part that is going to be hydrophobic. So it's going to have 2 parts, hydrophilic part and hydrophobic part. So in common we can say all membrane lipids will have a hydrophilic part and a hydrophobic part. So if we discuss, we're going to take a look at how these structures are made. The first one is for a phospholipid, it could be using 2 different backbones. It will have first the backbone of glycerol that we already have seen, the unit of glycerol. That's glycerol. And we also will have the unit of sphingosine. And in sphingosine, we will have 1 primary alcohol, 1 secondary alcohol, an alkene part with 13 carbons long, and an amino group. So you can compare these 2 molecules. You have this carbon 1, 2, and 3. The only difference is that you will have an amino part and a long hydrocarbon chain. It's about, I think, 14 carbons long. Now, to make a phospholipid, we can say the first kind of phospholipid is the glycerol phospholipid. You will have the unit of glycerol plus 2 fatty acids and 1 phosphate unit plus an amino alcohol. We do the structure for that, that will look like, so you have a glycerol unit that has reacted with 2 fatty acids, so we will have 2 long hydrocarbon chain, and allow me just to do carbons without counting, please. So we will have 2 fatty acids, 2 ester bonds, and then these are 2 regular ester bonds, 2 regular ester bonds, and 1 phosphoester bond. And then an amino alcohol. This is going to vary. If you take a look at my PowerPoint, we have different kind, amino alcohol. So that will be making a phospholipid. Now this molecule will have a hydrophilic part. All of this part is hydrophilic. And we're gonna call that head. And the hydrophobic parts, we're gonna call that tails. So we have, in this case, 2 tails and 1 head. These tails are hydrophobic because of the content of carbon. And then we have a hydrophilic head. So that will make a phospholipid. We can make a small symbol to represent a phospholipid like this. 2 hydrophobic chain and 1 hydrophilic head. And that's a symbol that is very common. You will see that very often to represent a phospholipid. Now this is a glycerol phospholipid. It's called glycerol phospholipid. If it is a glycerol phospholipid, it will have 2 fatty acids. 2 fatty acids.